x equal to 0, y upon b is also there, so y square equal to b square, that means y equal to plus minus b. Okay, so that means at x equal to 0, y is equal to plus minus b, and that situation also. So y is 0x and y plus b, and 0 and minus b. There are 2 points on the axis of y. The curve will also meet the y-axis at these points, 0, b and 0 minus b. So these are the 4 points here. What are the points? Minus a0, 0b, 0 minus b. Okay, so the curve is meeting the curve, the points here. Okay, this is, let me draw the first curve. And then if I solve this further, this equation, so what we will get, x equal to plus minus. Okay, x equal to minus a and plus a. And then what are the, and if I shift the curve to any point minus, suppose any single point a0, let me shift the curve. Shifting the curve here, shifting the curve, shifting the origin to the point, what I'm talking about, shifting the origin to the point a0, let me take. If I put x equal to a plus a by 0, same value. This is x plus a upon a square, and this is also whole square, whole cube 1.3, and this the same value, y square upon b square whole 1.3 is equal to 1. Same value. Solving this equation, we will get equal to this x plus a whole square upon a square is equal to, and this is whole 1.3 also, equal to 1 minus y square upon b square. This value, or whole 1.3, I'm sorry, this value is there. Equating the smallest degree term, so x equal to 0. From this x equal to 0, if I take twice x a whole square, if I open, and we will get twice ax, that is the smallest degree term. That x equal to 0, this implies that x equal to 0, the new y-axis, let me take the new y-axis, or if I find out the origin, degree at these points, because at this point if I find out the tangent line, the tangent will be 0 here. By d by dx, if I find out from this equation, d by dx, we will see here that it will be 0 at the point. If I substitute the points a0 and something, okay, and if I find out this point d by dx from the given equation, so we will get 0 here, solving this equation. So that means tangent at the point a0, putting a0 in the given equation, at that point d by dx value, if I differentiate this equation, we will get 0. It means at the point a0, the tangent will be 0. That means tangent is making angle 0 degree with the axis. So let me draw the curve here. There are 4 points here. This is x dash, y, and y dash. What are the 4 points? This is here a0. Curve is meeting the x-axis at a0 and minus a0 point. Okay, and this is another point. Let me take, this is 0b. The curve is also meeting y-axis at the point. This is 0 minus b. Okay, so if I just join these curves, there is no asymptote here. This point. This is the point. This is the curve here. Okay, so at this point, tangent is along the x-axis. Tangent is along the x-axis. So at the point, at this point, tan 0 is 0. I mean, tangent of that angle d by dx is 0. At a, let me take a dash. This is b point. This is b dash point here. So at a, d by dx, if I solve this equation, will be minus 1. Sorry, 0 here. That means tangent is 0. Tangent is making angle 0 degree with the axis of x at this point A0. That means the x-axis is the tangent here. And the tangent at axis is along the axis of x. So this is the curve. Okay, the curve traced here. We have obtained these 4 points, joining them, those 4 points on the axis. We have obtained the curve. No asymptotes here, because the curve is not, y is not infinity, x is not infinity at any point. So no asymptotes. Asymptotes will not lie here. No asymptotes. Okay, or asymptotes are not there because curve is closed curve here. That is not meeting the axis at infinity or at any line at infinity. So curve is of this kind. This is hypocycloid curve known as. Okay, this is the shape of the curve. So we found out the points first. A0 minus A0, 0B, 0 minus B after substituting the values. So this is what we have to obtain. At this point, theta will be pi by 2 or minus pi by 2 tangent of. At this point, at y-axis, dy dx will be okay minus minus infinity it is. Or this is tangent of minus pi by 2. Okay, so tangent of minus pi by 2, that means sine upon cos, cos is 0, then minus infinity. So at this point, the tangent is making 90 degree angle with this point. Okay, so at this point also y-axis is working as the tangent line, okay, on the point 0B. If I take x to the x-axis, with the x-axis it's making 90 degree angle, but here y-axis is along the, so the curve is meeting the y-axis at this point, so y-axis is working as the tangent to this point, or tangent is along the y-axis. Okay, so this is what we have to prove this. So this is the curve, second curve. This is a hypocycloid curve. So question number 3 we have done. Now let me talk about question number 4. Question number 4 or fourth question. What is that? Question number 4 here is, let me change this. For the question number 4 here. Okay, now question number 4 says trace the curve x equal to a cos qt, y equal to a sin qt. This is asteroid. This is the equation of asteroid. Let me check whether it is asteroid or not asteroid. Okay, so trace the curve test. Again, similar type of question. Okay, let me solve it. Solution. If I want to eliminate the parameter here with t, then what? Same thing, we have to make this clear. And x upon a here x upon a is equal to cos qt, and y upon a is equal to sin qt. Again, squaring and making cube 1.3 cube root of this. So cube root of this and squaring, we will get here cos qt whole power 2 by 3. This 2 by 3 we have done. Okay, similarly here y upon a whole power 2 by 3 is equal to sin qt whole power 2 by 3. What we have obtained here, this is x upon a whole power 2 by 3. Okay, is equal to, this is cos square t. Similarly from this y upon a whole power 2 by 3 equal to sin square t. This, let me take fourth equation, third equation, and this is the fourth equation, and this is first and second. So adding these two equations we obtain on addition of equations third and fourth, we get This is x upon a whole power 2 by 3 plus y upon a whole power 2 by 3 is equal to sin square t, well first is cos square t plus sin square t is equal to 1 here. Okay, that means again this is of that kind of question that x raised power 2 by 3 plus y raised power 2 by 3 y upon a whole power 2 by 3, okay, is equal to 1. Again solving this equation. Okay, so this is symmetric about both the axes again. This is a whole square. Both the variables action by are of square degree, even degree. 1.3 is okay, but square is also there. So both the variables are of square power, even power. That means the curve is symmetric to both the axes. Let me take that. So this equation we have obtained. Let me trace this equation. So equation we have obtained here, x upon a whole power 2 by 3 plus y upon a whole power 2 by 3 is equal to 1. This is the equation. Let me take fifth equation. So what are the conditions here? Let me trace this equation. This is Cartesian equation which we have obtained from this after eliminating parameter t. So this Cartesian equation solution first further. This will pass. Sorry, this curve is symmetric about both the axes. Axis of x and axis of y. It will be symmetric to both the axes, or about both the axes. The shape will be similar or like. Second point, it will not pass through the origin. It will not pass through the origin. As one is independent constant term, because of that it is not passing through the origin. Second thing. Okay, so if I, before solving it, let me find some values. Putting y equal to 0. Third point. Putting y equal to 0, we get y0 here. We will get x upon a, or x square upon a square is equal to 1, or x square is equal to, because q root of 1 is 1. So making q of both the sides. Okay, this is 0 here, then qing both the sides, so 1 q is nothing but 1. So x square equal to a square, implies that again x equal to plus minus a. Similarly y is equal to plus minus a. By putting x equal to 0, you will get that point. So what are the points here? So the curve the curve will cross or meet. Let me take cross the axis at the points. What are the points at which the curve meets the axis? At x-axis it is a0 minus a0, and on y-axis it will be 0 and a, and 0 and minus a. In this case, in place of b, we have on the y-axis, we have in place of b a. Okay, same, because same variable is there, a. So here the figure is of the similar type, but this is this point here. So a and 0 and minus a we have obtained here. So let me draw the figure again. So the shape of the curve will be, and what are the tangents there? Let me just talk about. And beyond those points, the curve will be negative. In this case also, if I find, let me take y upon a whole power 2 by 3 is equal to, this is 1 minus x upon a whole power 2 by 3. This implies that from solving this equation, if I put the value beyond or more than a, okay, x equal to 2a, 3, etc., then it will be negative value. So y square will be negative. So when x is greater than a or x is less than minus a also, if I take this minus a because whole square is there, so it will be positive, or x is less than minus a, then also, or sorry, minus 0 you may say, it is minus a only. If I put minus a also, it is minus 1, but whole square will be positive 1, less than minus a, not equal to a but minus a, then it will be, then the value of y square will be negative, So the curve will not exist beyond x greater than a and x less than minus a. So the curve will not exist beyond x is equal to a. While x equal to more than a, we cannot take positive direction, x cannot go ahead more than a. Similarly, and x is equal to minus a, less than x minus a, or we may say x less than minus a. X is beyond, let me write here, x greater than a, beyond x greater than a, and this. So curve will not be there. Similarly, on the y-axis also, similarly on the y-axis, similarly applicable for the y-axis, as curve will not exist beyond y greater than a and y less than minus a. Okay, beyond that also, what are the points here? The same type of points here. This is x-axis, y-axis, y-axis, x-axis, this is origin O. So here let me take points, similar type of point. This is a0, this is 0a, this is 0 minus a, this is minus a0 at this point. Let me join them. This is the point which we have to join. All the 4 points which are lying on the axis. Okay, so this is the point, common point here. Let me take this is the A point, A dash point. This is B point. Let me take this is B dash point. Okay, so here it is A minus A, A minus A. So these are the 4 points. Beyond this we cannot go. So this is again a closed figure. No asymptotes. No asymptotes will lie here. No asymptotes are there. Okay, so this is one of the requirements here. So the shape of the curve is of this kind. This is known as asteroid figure. This figure is asteroid. The equation of this is asteroid in this way. So this is the tracing of the curve of question number 4th. Let me talk about question number 5th now. Question 5th or question number 5. 5th question here. Question number 5 is, let me check what kind of question is that. Okay, now symmetric. What is the symmetric question? Is the curve will be symmetric or not symmetric? That is another point. So that we have to think about from the asteroid, from that, Cartesian equations. So first convert the parametric equation into Cartesian forms and then solve it by the same method as we described. That how So the curve is symmetric or not symmetric. So let me take next question here. Question number 5 now. What is question number 5 say? Let me first clean the. Let me clean this. Okay. So it is darkened here. Let me clean this. Okay. Question number 5 is, let me check what kind of that question is. Okay. Sorry for this. Now question number 5. It says trace the curve x equal to a cos phi and y is equal to a sin phi. A sin phi. Now this says that is just equation of circle. Undoubtedly, let me now is simpler question. Solution. So eliminating the parameter here, elimination of the parameter. Let me write elimination of parameter. The first method we are using here again. Elimination of parameter. First method. So applying the first method, elimination of parameter, converting that into Cartesian form or Cartesian equation, and then we will solve it the same way as we are doing the previous questions. Question number 8. What does it say? Let me check it. Here it is squaring and then adding. So squaring. Let me take first equation. It is the second one. Squaring first and second and adding. We get, or on addition we get after squaring. We squaring both the equation first and second. After that adding them, what do we get? Here x square, here it is y square, would be obtained here a square cos square phi plus a square sin square phi. If I take a square common, it is cos square phi plus sin square phi, which is equal to a square into 1. As since sin square theta plus cos square theta is equal to 1. Trigonometric identity, this is simpler. We know about this. So this is a square only. So x square plus y square is equal to a square. Now in this case, simple equation. If I take, this is the equation of a circle with center 0, 0 and radius a. Simple. So this is the standard equation form. This is the standard equation of a circle with center, in this case 0, 0. No center here. X minus 0 whole square plus y minus 0 whole square equal to a square, and with radius a, center 0, 0 and radius a. What is the equation here? So circle, the figure of circle, we know about this. So the center is 0, 0. If I take a as the radius and draw a circle, suppose this is a here, a point, joining them, this is the point here. With the circle 0, 0 center is 0, 0. This is O origin, center 0, 0, and this is a point. Let me take a0. This is 0, a. This is 0 minus a. Center. This is minus a0. So radius is a here. Is a radius. This is the equation of a circle. Simple. Then no need of this, or we can just take x square equal to a square minus y square. If I put any value other than a, so a square is else. Or this is a standard equation. If I put x plus, this is x minus h whole square, y minus k whole square is equal to a square, suppose, or r square. Here h and k are the center of the coordinates, or sorry, center of the circle, and a is the radius. Similarly, here 0 is the center, because in place of h and k we are having 0, 0. This is the standard equation of the circle. This is the curve, question number 50 here. Simple. This is standard equation we have obtained. This Cartesian equation is of the standard equation of a circle with radius a and center 0, 0. This simple we can draw. Okay. No asymptotes, no tangents. It is symmetric to both the axes, because x is square, y is square. Both have even powers. Thus, so we can just describe this. That this curve is not passing through the origin, because this a square is independent constant term we have obtained, and x square, y square both are even numbers, so the curve will be symmetric to both the axes. This way we can describe. After that we substitute x y equal to 0. If I substitute, then x square equal to a square, x equal to plus minus a. The curve will meet the axis of x at point a0 minus a0. Then if I put by x equal to 0, y square equal to again plus minus a, y equal to plus minus a. So that is also the points. So all these 4 points are on the circle. They have the similar type of distance. So this is the radius here. A is working as the radius. So this is the circle. We can draw this circle symmetric, about both the axes, not passing through the origin because constant term is there. This is how we can draw the curve here. Okay, so this is Cartesian equation of the standard form of circle. Standard equation of a circle. No need of other things here. Now let me talk about other things. Okay. Now question number 6, let me talk about. What is question number 6? Let me talk about that. Question 6 says trace the curve. Okay, this is x equal to 1 minus t square upon 1 plus t square, and y is equal to, this is 2t square, sorry, 2t upon 1 plus t square. Okay, this is second equation. Let me take, this is the first equation. Again squaring these two equations and then adding. Let me add them and square them. So elimination method, let me apply. So applying the first method. So applying the first method. The first method, or elimination of parameter. Elimination of parameter method. This is your first method, elimination of parameter. What we have to do is squaring first and second and adding. Again squaring first and second and adding, and on addition we get first squaring and then adding. So we get these two equations as, this is x square plus y square. We have left hand side we have added, and then right hand side are 1 minus t square whole square upon 1 plus t square whole square, plus this is 2t whole square upon 1 plus t square whole square. Simple. Now let me solve it further. The denominator is the same, so LCM is same, 1 plus t square whole square. In numerator we have obtained 1 minus t square whole square. Yeah, this is 1 minus t square whole square, undoubtedly. This is 1 plus t4 minus 2t square, simple, whole square of a minus b whole square is a square plus b square minus twice ab, that means, or we can write a square minus 2ab plus b square. This t4 can come after minus 2t square, doesn't matter. Plus this is 4t square here. So what we have obtained? The numerator we have obtained this 4t square plus square, this minus 2t square. We have obtained here 1 plus 2t square positive plus t4 divided by 1 plus t square whole square. Now in the numerator we have obtained nothing but 1 plus t square whole square. If I open 1 plus t square whole square, we will obtain the same thing. 1 plus 2a into b, that means 1 into t square, that means 2t square, plus t plus b square, that means t4. So the same thing we have obtained in the numerator, and in the denominator also the same thing. This is equal to 1. This cancel out one time. This is equal to 1. That means this is also equation of a circle. Now with radius 1 here. So this is equal to 1. Let me write here. So this equation, as we have seen, yielded to 1. So x square plus y square equal to 1. Again, this is the standard equation. This is a Cartesian equation obtained after elimination of t, the parameter. After t, the parameter. Okay, so this is the equation here. And what we have to do? It means this is the equation of the circle. This is standard again. This is the equation. This is a standard equation form. This is a standard equation of a circle with radius 1, with the radius 1 and center 0, 0. Again, with the radius 1 and center 0, 0. Okay, because this is x, x plus x minus a, x minus h whole square plus y minus k whole square equal to 1 square, or r square. Here r is 1, radius is 1, and center is 0, 0. So this is